So hi everyone, and welcome to today's Android254 meetup. This is our main meetup, and we have a lot of sessions lined up. So I don't want to take much time so that we can have enough time for all the speakers to present. So I am your host, I'm Harun Wangereka. I'm an Android developer and also co-organizer for Android254 and Kotlin Kenya. Yes, so as I always start with mentioning our 2021 plans, we have the monthly meetups, which is every third Saturday, which are virtual and we record them. We have a bit of delays in editing these sessions, so that's why we have not yet uploaded any sessions, but we'll upload all of them in due time. Secondly, we have the hackathons every 2 months. We are yet to start our first one, which is on the plans. So keep on the watch and be ready. We also have the quarterly in-depth sessions where we just focus on certain topics and give workshops or maybe a mini conference on the same. This is yet to start. And once we start, we'll also post on our meetup and also social and maybe Telegram too. So we have the showcase nights where we build something awesome. We had our first one, which was last month, where we had a couple of people showcase what they have built. Yes, so we'll also be having another one this month, later on this month. So I'll urge you to tune in. As maybe for those who attended, so the format, it was very, in case you have something you've built, maybe it was not even related to the theme of the showcase, but in case you have something you've done over the month or over the week that you feel like you want to share to the Android community, we always welcome it. And also, we have a plan to have more speakers. As you've seen, we have 2 speakers per sessions every monthly meetup. And good thing we have speakers lined up to the remaining part of the year, but still make your submissions as we still have more sessions. So for speakers, we're targeting Kenya and all of Africa to begin with, since it's a Kenyan meetup. And then we have Googlers, GDEs, and dev evangelists once in a while coming to maybe present what they have or what they are not, their knowledge. And then in case you're in this meetup and you need to maybe speak on these sessions, worry not, maybe submit your sessions and we'll be sure to get in touch with you. And lastly, one of the plans we generally focus on this year is having quality in all areas. This means we have quality speakers, we have quality sessions, and overall, we have people developing quality libraries and applications from Kenya and maybe going above Kenya and beyond Kenya. Yeah, and as I always say, in case you have something that you need us to do, feel free to reach to any of the organizers and we'll be happy to plan with you or plan amongst ourselves to organize for that. Yes, so that is all about our plans this year. In case maybe there is something you feel we've missed, we always appreciate feedback and we are always open to feedback. Yes, so we have, as I mentioned, we always happy to host amazing speakers from among the attendees, the community, and so on and so on. So in case you're here and you feel like you want to present, please feel free to submit your session and we'll get in touch. So we have a couple of people who
So morning everyone, my name is Wachira Nduati. I was supposed to be the very first speaker for the day. I don't know if we should just proceed or just wait for Haron. What do you guys think? Okay.
So hi everyone. So I'm sorry for that. I think my internet just dropped. Apologies for that. Let me quickly maybe just resume. So you can see my screen. Can you see my screen?
Yes.
Yes, so as I was mentioning before I dropped off. So if you have never given a session, please don't worry. We got you and we don't discriminate. And we are happy to maybe kickstart off your speaking career. So here is the form for those who want to. I'll share this on the chat in case you want to submit a session. Yes, and also, so we have another collaboration just to highlight. We have this Android series where in case you've not, targeting mostly for those who have not maybe known much of Android or maybe are at the beginner or junior level. So we have David Odari and also Ronnie, and with collaboration with DSIMO University, we have an Android series where we have 4 to 5 months of them teaching you basics of Android and also sharing their experiences as they go through the session. So in case this sounds interesting to you, I'll also share the link for this. Maybe you can join. We have a Kickstart call today, which to kickstart the whole series and all that. So in case this might be interesting to you, please feel free to maybe RSVP and join the team. So I'll also share the link on the chat just after the presentation. And also, so today we have 2 amazing sessions. We have the first one, which is a very sane guide to Android testing. I know a lot of people have been asking, how do you do testing in Android, both UI, unit test, and also integration testing. So if you're curious on the same, this is your session. And we also have another amazing session for graphics and games with SDL and Vulkan by Benson. So I'll not, yeah, so this is also an interesting session where you get to see how you can do maybe graphics and also do a bit of games on Android. So stick to the very end to see these 2 amazing sessions. I'll not maybe speak more about them. I'll not want to preempt what the speaker has. So we have upcoming meetups. We have an IO 21 recap, as we all know. Google IO 2021 is next week from May 18th. And as usually for Android254, we usually have a recap meetup where we just discuss what's new, what was announced, what do we need to look out for. So we are going to schedule this meetup. Most likely it will be the first weekend of June. So keep an eye on it. It will be like a conversation. So in case you are here and you also, maybe you'll follow the IO live, please feel free to come and share what you've learned. We don't have like any specific speaker, but we'll want it to be like a conversation where we all discuss what has been released, what was the most exciting announcement for you, and so on and so on. So please watch out for it. So next month, we'll be having 2 meetups also. We have the IO recap and our monthly meetup. And also we have a showcase session end of this month. So in case you have something to build, we have decided the theme. I think Wachira, is it Wachira? What was the topic?
It was to build an interesting app using the Array SDK.
Yeah. So we also schedule that meetup. And in case maybe you want to see what people have built, you can see that. Yes, so I think talk to us in case as I said, we appreciate feedback very much and new ideas. And also in case you want to give your first talk, in case you want to us to maybe collaborate on something, those are the people to reach out for. I do not work alone. We have Tamara Frank and we also have Candy Jackie. She's the one who speaks to you when you do the speaker submission. And maybe just to highlight something, once you submit your session, let's say you've submitted for August and you don't hear from us, you don't have to worry because when it is like the first weeks of August, we'll reach out to you and maybe organize more about the session. Yeah, that is what you usually do. So for example, for June, we are going to reach out to the speakers, maybe later in the course of this month or early next month. So in case you have submitted and we have not gotten back to you, don't have to be worried. And that is it from my end. As I said, I usually forget to introduce myself. I'm Harun Wangereka, an Android developer. So Wachira, I'll let you take off the session.
Okay, thank you very much, Harun, for that. Give me a second to share my screen. Okay, sure. Ignore the very many tabs. So let me go into presentation mode. So for those of you who don't know, so today's session, the session I'll be presenting on is the same guide to Android testing in Android, in case you forgot. Apologies, I still have to admit people. So who am I? So my name is Wachira Nduati. I currently work for the Nigeria Digital Program, not as a dev, but open to future Android dev roles. I'm also an ELC community member and an Android track mentor for the GADS 2020, whichever. I also freelance as an Android dev. I'm currently freelancing for a small Spanish company called App. And of all the SDKs in the world, I'm in love with any maps SDK. I'm an adventure rider and a forest hermit. Moving on. So let's get our hands dirty. In case you forgot, still, yet again, so testing. This is a getting started with testing guide for beginners, pros, and novices. I don't promise to know everything, but I'll give you a head start with a little I know. The session is modeled in the very way I learned testing through trial and error. So please sit back and enjoy the show. Session will cover UI testing, unit testing, and hopefully take particular interest in that one for hopefully integrated testing. So basically, the biggest challenge for me when getting started with testing as an Android dev was actually even finding a good resource that would get you started with Android with testing. It always left you feeling empty. I would only provide one particular thing, or in some scenarios, say for instance you're a beginner and you're trying to find, say for instance something like a room tutorial. You'd find that they're probably already doing dependency injection, and it tends to overwhelm someone who's trying to start up. Say for instance you're learning room, and then you just realize that you actually have to figure out what MVVM is, what live data are, and what view models also are. So my testing, this particular case in point will take a view of testing where anyone can get started, as simple as is. It will take an overview of everything that you might need and some of the ambiguous terms that you might find when you're getting started that might hamper you getting started into Android testing. So next slide. So the very first question is, why should you test? So probably most of us bedroom coders, you just write your code and then you just do the manual test where you're just clicking a button on your phone or on your emulator or on your device. Sorry?
Just a bit. Can
Okay.
you maybe stop sharing? Maybe I check something.
Okay.
There is something who is saying they're still seeing my screen.
I think you'll have to. Okay. Sure.
Yes, I think I'm not sharing. So I think the fillers, I think only Wachira is sharing. I hope you have you can continue. Sorry for interrupting.
Okay. So the very first issue is, why should you test? And I was talking about how most devs will probably just use the bare minimum. They'll just press a button in your app because you already know the journey map that a user will use in your app, and you'll get the results that you expect. That the problem is when your code base grows so big and you have so many enhancements and features, it gets to a point where you might overlook one thing and it ends up breaking your entire structure. So some of the key lights that you might find that will give you a reason as to why you should definitely write tests are bugs are found easily and a lot quicker. Number two is unit testing saves time and money, and this pretty much piggybacks on the very first point. Third one is unit testing provides documentation. Imagine moving into a new company and you have to understand how the app actually works. The idea is that when you write tests are supposed to be small and modular, and also specific. We'll talk about assertions in a few, and we'll talk about scope. So now that you've broken up your code into smaller reusable chunks, that also piggybacks on the very third, or on the very fourth point, it's easier for someone to actually be able to understand what your app actually does and how it actually works, following through with the test cases. Because the idea is you're testing every single unit, and also you have your, depending on the type, on the kind of test that you're doing, it will also follow a user journey until the end result is found. The fourth one is reusable and reliable. Remember, we're breaking up our code into smaller reusable chunks, that make it easier for us to actually test our code. And the fourth one is unit testing helps gauge performance. So if you want to look further into this, you can definitely look at the link that I provided that I've highlighted in the yellow color at the bottom. So moving on to the next, give me a second, into the next screen. So before we get started, so you're probably already wondering, maybe most of you probably already know, and some of you might not be aware of where to find this. But when we're talking of the tests in Android, the particular folders that we'll be talking of specifically, under your apps folder, I'll be showing you in a few. Let me see if I can just interrupt myself and just give you this. So in your app folder, let me just try and minimize everything. So in your app folder here, you find that you have the three folders. We tend to call them sources, and this is where your production code goes, and then this is your Android test, and this is your test. I'm reading the brackets at the end, so this will dictate what kind of test you're writing and where it should go. Let me go back to my presentation. And also we have a couple of Gradle goodies that you should definitely be looking out for when we're talking about implementations. When you're talking about test implementation and Android implementation, the two talk about two totally different things, and I'll be highlighting about that in a few. The next is a library that you can definitely go for, which is the truth library that makes it easier for you to actually read your tests. If you're interested in figuring out a bit about testing, I had created an earlier repo that I was playing around with tests all over, so you should definitely look it up. So the three kinds of tests that we're going to be looking into: unit tests. And unit tests are broken up into two. We have local tests and instrumented tests. With local tests, the biggest difference is that local tests run on the JVM. That's the Java virtual machine. But instrumented tests in all scenarios, they'll either run on your emulator or on your device, because they're literally local tests, but not they're utilizing some of the Android resources. Say for instance, something like context. With local unit tests, they cannot tap into some of these Android resources. The libraries that you'll be using for this are JUnit and Mockito, depending on which one depending on which test you're writing. I'll also talk in a few about the pyramid you're seeing at the right. The next one is integration tests, and before you even go to that, you should note that unit tests should take up 70% of your tests, because remember, this is they tend to form the baseline of all your tests that you write on your app. Third one is integration tests, which should cover 20%, and will be using you can utilize JUnit or Mockito test. With integration tests, it gets a bit confusing when you try to figure it out, but I know it will be literally the very last section that we cover. So I'm hoping I'll be able to talk more about it. Talking of the folder that it should be in, or the source set are the folders that I'll show you in a few, the ones that I'll show you right now. So with the integration tests, because they're actually utilizing the Android resources, they're only located in the Android test source set. But with unit tests, you'll actually find them in both. Because we talked of local will only ever be found in the test folder, in the test source set. But in the instrumented unit tests will be found in the Android test source set. And finally, we have the UI tests that should take up the least amount, the least size of your tests. That's 10%, and we'll be utilizing. Sorry, I actually wrote Espresso, but you'll be utilizing something like Espresso that comes natively by default in Android Studio. But in this particular case, we'll be using Kakao because it makes it a whole lot less painful when you're writing out the test. We'll also do a small test on automating testing using Roboelectric, and you will find out how flaky it can be. So the graph to the right, what does it imply? So with the increase in the size, with an increase in the size of the tests that you have, it also leads to it's not directly what do I say? Like fidelity, execution time, and maintenance will depend with how productive your code is in terms of those particular key terms will depend on what kind of test you're running, and also the size of the test that you're doing. I don't know if that makes sense. So the next screen, what makes a good test? So scope. Remember those items I was literally just trying to talk about right now. You should know that your test should only test for one assertion. The reason is to this. Multiple assertions will just make your testing complicated, and in some scenarios your tests will fail and you'll not know what exactly led to the failure of your test. And towards this, you'll actually find that even in the naming convention of your tests, we're trying to force one assertion so that the test itself is descriptive as possible, to give you better results. So with scope, how much of your code in the function is covered by a single test? I don't know if that already gets home, because the idea is you've broken up your code into simpler modules. So you have your scope, and then you're trying to just measure for that one thing. Say for instance, it was a login screen, and you're trying to compare what you have that confirm password, you have that password, and then you have the confirm password. You're not trying to test for anything else. You're just trying to test for, is the confirm password the same as the initial password that was passed? You're not trying to look if the password is an email that was produced. Does it match the requirements of a good password? No, you're just looking for one assertion. So the question is, does it actually measure up the scope that you're trying to look for? Does your test cover all the endpoints that you might need? Because remember, when you're writing test, you're actually trying to break your app. But then we will also talk a bit about TDD, which will be the second slide after this. Next one is speed. And how does speed affect your code? If we were to go back to the previous screen that we were on, which is this one, you realize that as we go up, the kind of test that we're running starts to be slower. The fastest tests that run are unit tests. And to even go deeper into that, they're actually local tests that only run on a JVM. They don't have to use an emulator or anything. But the more resources that we actually need to use, and the more dependent we are on something like an emulator, the slower our test will be. And the problem with something like this is it will make you as a developer, if you know that your test will take you probably like 10 minutes to run, it will make it harder for you to actually follow the paradigm where you actually have to write your tests. And the next one is fidelity. Fidelity is how close our tests are to real scenarios. Ensure that our app works well in the real world, and also to avoid flaky tests. tests that sometimes succeed and sometimes fail. E.g. testing for numbers while depending on a random number generator. And the final thing I should probably mention is that an increase in scope typically leads to an increase in fidelity, but a decrease in speed as an expense, and vice versa. You should also note that it's not all scenarios that you can only test one assertion, but in some scenarios you might have to be forced to, so there is no one perfect test that you can write. So what is TDD and why should we even do it? So with TDD, this is test-driven development, and someone was actually asking some time back, can you actually use TDD when you're writing UI tests? So the idea is you can actually do that, but what is TDD, to be frank? So test-driven development is where you'll create a signature. That's the very first step. You create a signature, a function signature of what you want to test before you actually implement that function or that method. So that once you create your test, because now you're creating a test anticipating you'll be writing code for that particular test. You'll be writing code to fulfill that test to make it run successfully. But now you're running it before you even have the meat in the function. So initially it fails. The idea is the very first time you're running your test with TDD, it's supposed to fail, so that then you implement the content in your function, so that now it runs. And then again, you have to tweak it a bit. You tweak the test. Maybe you now write, because we've already asserted one specific thing, we move on to the next one. Remember, you're trying to break your code. And then again, you also need to remember that all user input is evil. So you're trying to make sure that you've covered everything. Remember, key point is being scope. So you write the test cases for that function, and then write the function logics that the tests pass, and you iterate like that. And yes, it tends to be very repetitive, but the idea is it safeguards your code. And the next one. So we're finally getting started with this unit testing. So like I said, unit tests, the unit tests are actually broken into two. We have the local tests and we have the instrumented tests. And I don't know why I didn't even break them up into two. But with local tests, they run on your local machine. That's the JV. They run on the JVM, and basically in your local machine, they're very fast, like we said. And if you can remember from the pyramid, from the testing pyramid, they occupy the bottommost, and they're supposed to be the base of all your tests, and they're supposed to take up at least 70% of your tests. Just keep in mind logic. They're supposed to test the logic of your app, and they will, in most scenarios, just use JUnit 5. In this case, we'll actually use JUnit 4 and Mockito. Mockito is a library for mocking some of the Android resources that you might need. So they've got to be fast, lightweight, and focused in order so that they can achieve high scalability. They're really easy to define because most times we're just testing a single method in a single class within an application. They'll also give you a high degree of focus on the origin of failure. So a practical approach. We will be doing a simple practical after this, but the idea is you can actually look at this and have an idea, of what it entails. So the idea is you already have your login util, because obviously we're trying to target something that will not utilize talk of local tests. For now, ignore instrumented tests, because we talked of unit tests being divided into two. If you classify them deeper, you get them as two different units. We have the local tests and we have the instrumented test, which will actually be the next one. So this particular case in point is for local tests. So assuming that you've created a login util, as I was talking about earlier, the idea is you already have this functionality. Now, for now, I'll throw away TDD. We're going to do this practically, but assuming that you've created a UI that a user now is supposed to log in, and now you're looking to see if the passwords are similar. For now, I used an object. Actually, this is something that was stolen from a very awesome YouTube playlist. I'll actually be providing some of the resources that I used for this. So you're trying to log in, and this is your login util. I'm using an object so that you can get an idea on how you can actually utilize some of the annotations like before and after in your tests. So for now, you've created your object and you have to annotate it with runs with, because remember we're using this particular library for you to be able to run your test in the local JVM. So we're checking to see if the passwords match, and assuming that we're getting two strings and we return a Boolean, it's supposed to check if the password that was the password 1 and the password 2 are actually correct, and then it returns the case that comes out of this. I don't know why this thing is trying to hide my whatever. I don't know if I can drag it. Okay, let me just use my other screen. And then the test.
Wachira,
Yes.
you'll have to share your entire screen in case.
Ni venye kamehang hapa chini. I'm sharing my entire screen. Lakini ina shida. I have another screen I'm using. It's okay.
Okay.
And then our test. Our test will be, it has to be annotated at test. And in this particular case for local test, remember when I talked about using assertion, like our tests being, the title of our tests being descriptive as to what we will get out of it. Because you want to know, remember you have to test if your assertion actually plays out correctly, and you also have to try and break it. So when you break it, it has to have like an assertion of does not return true, or maybe returns false. In this particular case, we want to see if we pass two similar passwords, and please note the backticks that I've used. These are particularly only used in local tests. When you're using instrumented testing, you realize that you cannot use the backticks. In that particular case, we'll start utilizing something like the, what are they called? The heck, they look like hyphens. Underscore. So for now, we are using that the key name, that password is similar and returns true. So for var, we create a result, we initialize a value as a result, and then the login util. Remember, we used an object, so we don't have to instantiate. We don't have to create an instance, and then we call the method directly, and then we pass the two values that we have. Those are the two strings. And then assert that this is true. This is actually supposed to be false. I just realized that I passed 2 as the let me edit it. It's supposed to be password 1. Sorry. And this assertion, then we assert that. Note that assert that is a feature that's only provided when you're using the truthy library that I showed you about. That the truth library that's provided by Google that makes it easier for you to actually read your tests. So we will hopefully test how to actually do this without the Google Truth library. But the idea is that now you assert that, pass the value that the value that you're trying to check for, and then dot whatever you want to check for. We want to see if it actually returns true as per what we had actually highlighted in the naming convention. So the next one is instrumented testing. With instrumented testing, I don't know if I've already gone to the next one. Sorry, I'm trying to navigate with two different screens. So instrumented unit tests, the unit tests that are run on Android devices and emulators instead of running on the Java virtual machine. These tests have access to real devices and its resources and are useful to unit test functionality, who cannot be easily mocked by mocking frameworks. An example is a test which validates a parcelable implementation. So exactly just that. So in this particular context, I think I found it really hard to try and simulate a need where I would be able to give an example of how to do this. And the easiest one that I found online, other than the parcelable, it seems to have been used by so many people. But the good thing about the parcelable implementation is Android Studio actually does it for you. I don't know if you're supposed to test it, maybe it's important, but that's literally the only example I could see. The other example I could see was comparing a string resource and a string, where if you need to compare the string resource, you need to have a context. Remember, a local unit test will not have access to your context, to your device's context. And now that you're using an instrumentation test, you actually have access to some of the resources that are provided by Android. And also they can be annotated as medium tests. Unit tests are normally annotated as small tests, just in case you come across something like that. UI tests are normally annotated as large tests, FYI. So the practical approach is that one where we're comparing the string resources. So I've created a class. So at least now this one is a bit different from the object. With the class, you'll actually have to instantiate it. And the idea is we're creating a util class for comparing resources. So we have we will be comparing a string that we pass. We need a context in this particular scenario. So now that we actually need a context, we have to take it away now. We have to take it away from being a local test to being an instrumented test, because now we're utilizing resources from the Android framework. So the function itself is as simple as this. Sorry about that. So function compare strings. We pass in the context, the ID, the resource ID, and then the string that we're going to be testing for. And then we have the function returning a Boolean, and the Boolean is dependent on what is returned from the two. So when we get the context and we get the string, then we check if the value of the string from the resource ID equals the string, and then we return the Boolean from this. And the test class in this particular case, well, it's called the compare string test. Note that the naming convention for most of the tests, other than the name that you give the file, it's supposed to be appended with the test, so that it's actually easier to even match them up. And also the functions will only have the word test appended to them if you're automatically creating it using, if you're automatically creating it using something like Android Studio. But you also have the freedom to do this on your own, because in some scenarios you might also you might want to create the setup and tear down functions for your tests. So in this particular case scenario, we're comparing strings to test if they return true. So the value resource, we're initializing the class that we already had. Then we're getting the context from the application provider, and then we're getting a result. But we're comparing the context. We're using the context from the very first method that we made, and then we're using the string to compare with the name of our app, which is our app. And then we're starting that the result, which is what we get from this, is actually true, and it should actually check out. So if it was false, we would have probably returns false, and then we would have given a false name here. So the final, the second final one is UI tests. So UI tests are supposed to, they're also called E2E tests or end-to-end tests, and they normally simulate a user's journey on how a typical user would use your app, from the very first screen maybe to the very last screen, or the very first screen to a particular destination in your app. And you're basically supposed to just test for the state, to test that the state actually turns out as is. But the problem, one of the biggest problems that I personally found with this, when I was starting off with UI tests, you'd find yourself trying to test and see if something that so there's this problem where you might try and test for static widgets, because everything in your screen obviously is a widget, but that is a wrong thing to do. The idea with UI tests, from my own understanding, is that you're only supposed to be testing things that might actually change on your screen. Yes, it might come upon a time where you might want to actually look to see if something is actually visible. Maybe you didn't use your constraints correctly, and maybe you're scared that the device screens might change, and that's why we actually have that Firebase testing thingy. So the idea is for you to test things that will be, to save yourself on time and to save yourself on stress. Just test for things that are dynamic, something that you might change. Maybe you're looking to see if a dialog actually shows up. Maybe you're testing to see if if a user's username will actually change, something that's dynamic. That is the idea. So they used to verify that the UI has a specific state, that the state is actually checked. Tests that check if many or all components of your app work together and well, if the UI looks like it should. Simulate what a user may be doing with the device. And like I said, it literally uses widgets. It needs to be run on a real device or an emulator, and can be done with Espresso. And there's an extra probably a takeaway exam for you guys. You should definitely look out at Monkey Exerciser. Again, I'm saying I think I wrote it wrongly, but Monkey Exerciser is what's it called? It's an ADB. It's an ADB. It's an ADB command that tries to break your app. Remember, when you're writing test, you're trying to break your app to see if there's something that you left out in your code. So with Monkey Exerciser, it tends to click all over your app. So note that if at some point in time your app might have to wait for something, and that wait time might lead to the breakage of your app, you should definitely use this because it will actually find it. Other than you being able to simulate what a user might do, remember that UI tests are just doing what you probably do manually. But the idea is now that they're already automated. Once you've added so many features, you don't have to actually go to every single screen doing it manually. Now your UI tests are doing it automatically, but with the Monkey Exerciser, it will literally go to every single screen and try and crash your app. So definitely try and look into that. And a practical approach when using Espresso is something like that. This was taken from the Google I/O, I think 2018 screen. So you're starting from your home screen, and you just started your activity. The idea is there are a couple of things that you have to look at when you're writing UI tests. You first have to find the view that you're actually trying to do something to, and you either perform, and then you can also assert. With the assert, you can actually check if it matches, check if something is displayed, check if a certain text checks out. So in this particular case scenario, we have on view. On view has to be there, and then we're trying to find an ID. We're trying to find a view that has this particular ID. Remember, we're first trying to find the ID so that we can then perform something to it. So the idea is we've already found our fab, and then we clicked on it. When we click on it, the idea is it might probably take us to a different screen where we then have to find another widget that we can interact with. The general idea of this particular app was a Notepad app. So you'd click on the fab ID to take you to a create note screen, and then you'd you'd find the task title, and then you type title, and then you'd find task description, and then you type the description that you want, and then you click on the save button, and then you'd only assert if it matches the title that has been displayed, because now you're taken back to the initial screen and you're just checking. You're just looking to see if what you expected to see has been done. But the general idea is what you literally just do manually. So the very second last screen is integrated testing. So from the definition, this is one of the definitions that I found online, that they're broadly meant to test what the integration between different modules or components is working. Generally, these tests are medium-sized and should comprise about 20% of the total tests written for your app. In Android, a simple example of an integration test would be to check to see whether clicking on a button for a particular activity takes you to a different activity. Because these tests run on a real device or an emulator, they tend to be much slower than unit tests, and we typically want to run them a lot less often. But then this was one of the definitions that I found, which was a bit conflicting, and that's why I didn't delve deeper into this. Maybe this is an avenue for doing an in-depth review into testing, specifically concentrating on something like integrated testing, a bit about mocking, something like using Mockito and stubs. Because the idea with integrated testing, from a different definition, I found that the guys mentioned that in as much as it almost, looking by the definition we currently have, it almost tries to imply that a UI test is an integration test, where to some extent is actually true. But then in a different context, you find someone else explaining that integration tests are supposed to be tests that you write for things that a user might not be able to interact with, something like a service, something like a database, which tends to be all the more conflicting for me. So if you'd like to check out some of the resources that I used to compile this, you can find them in there. And I think other than that being almost the end of my presentation, I'm going to show you, give me a second, let me exit out of this. I'm going to give you a small overview as to how you can actually do your tests. So the very first one, give me a second. So the very first one that we did was the what? The very first one was a local unit test. And when I was talking about the source sets, your local test should be located exactly here. The app that I created in this particular scenario is supposed to be a calculator app. I really pray to God that it does not crash right about now. Let me just run it. It's a calculator app. I'm really trying to rush fast. Give me a second. Please don't show me. Let me close this up. So basically, I created a calculator app. Let me just show you how it looks like instead of having to wait for that design on its own. Let me just. In the meantime, as it loads, okay, it's loading. Okay, I think it actually loaded. So this is what I created. It's a simple calculator app, and I think I tried to bite more than I could chew. I think I have more respect for calculators right about now. So the idea is to be able to just do every single thing that we tried, every single thing that we tested for. So the very first one being a unit test, and specifically we're delving into local unit tests. So the idea is you're testing your util, because your util will basically make up your what? Will make up your logic for your app. So the very first thing would probably create a util app for a util code base util class. I don't know if I created a class. Oh, okay. I created an object. So the idea with TDD is you're not supposed to create this first. The idea is you already have the implementation, you already have your class, and now you're supposed to first write your app. First write your test. So let me first go to my test. But then how you come about writing your test would be this. Apologies for this, that I already written this. But the idea is once you've created your object, the reason why I created an object and the next util that we're going to be testing for is actually a class. So that you can see how you can use the before and after assertions when you're writing your tests. So in this particular scenario, if you've already created your object that you want to test for, remember with TDD, you're just supposed to create a framework of function signature of what you're going to be testing for. It only makes sense that you already create your object or your class, and then the next thing is to create the test. So you just come to that, or you can click on Control-Shift-T, and you'll be able to create your test. Remember to go with JUnit 4. I think automatically it goes with JUnit 5, but most of the resources I've been looking at online have been saying that there have been some issues with JUnit 5. So definitely go for the most stable one. That's JUnit 4. It gives you the opportunity, the freedom to create the setup and the teardown. I'm going to try and fix this one a bit. Remember, I had already created this. I don't know if I already told you this. I already created this to avoid embarrassing myself when I'm working on this thing. So I'm just going to change it a bit. If you had classes, if you had methods in your particular implementation, they show up here. And Android Studio would automatically create stubs for you to just start off when you're building your tests. But remember, you're not supposed to have them when you're following the TDD ideology. So let me just create that one. And then you ask, where will it go? Remember, this is a local unit test. This is a local unit test, so it's supposed to be in the test source set. So go with that and create it. And now we have this. Now let me just test back my content. Let me just do this. I'm just going to comment out some of these things. But the idea is that my calculator, because I have my util classes, the idea is I'm supposed to create now the function. Say for instance, I'm creating literally that function that's just beneath that. The idea is I will be taking in two values. That's num1, which is a float. So why am I using a float? When you look at my screen, you notice that there's a point. When I was creating this one, I was trying to emulate the calculator that's provided by the Redmi phone. So you'll realize that it has a point. So the idea is if you went with an integer, it would definitely break your app. And probably if I gave you this app to play about with, most of you would definitely just go for the zero division error to try and break my app. And I tried to be smart about that, and I tried to remove it from the app. So now that we already know that we're going to be playing around with floats. Floats will be easier for us and it will be less painful for us, especially when you're doing divisions and if someone decides to put in a value that's actually a float. And then we have num2, which also happens to be a float, and this returns a float. And multiply will be num1 multiplied by num2. And I'm supposed to put in spaces in here. I don't know why this is happening. Oh, sorry. Okay. Oh, and then again, I actually forgot. So for now, I'll just return false. Remember, our function is supposed to fail the very first time. Instead of leaving it as blank, return false. Oh, what is up? Oh, sorry. Return what? Return 1.2. I don't know. 1f. So you find that, so this one was not supposed to return a true or false. We'll be comparing that in our test. But the idea is the very first test is supposed to fail. We didn't pass in the content that's supposed to be there, which is this. I just passed something that I will definitely be testing against to make sure that the test first fails. But remember, if you are actually doing this in the real life world, it's basically supposed to be false, so that you then work on the content of your function. So now that we've already created this, we first have to annotate it with @run with remember JUnit4. Sorry about that. Let me just remove this. JUnit4 class. Kama kunaibisha leo. So that, and then we start now defining our functions. So the function that we're testing for, it has to have that annotation, the test annotation to mark our tests, and that is the function that we're testing for, multiply. So which is the best name? Remember that we can use the backticks to be able to actually, you can almost write your naming convention can actually be a sentence in this particular scenario. So we're trying to see if so our test ideas. So this is a multiply function. Check if multiply of values 1f and 2f return what 3f. Oh no, it's supposed to be multiplying. So 2f return 4f, and then we pass it as a value. We then create a function. So the idea is we're going to instantiate that we're going to get the value of our object value using this particular function. So multiply. Sorry about that. Yeah, writing when someone is looking at your code inaenda from 100 to 0. And then we're going to pass the two values that we already know. So the first one will be 2f and 2f. This is definitely going to fail. So we're going to assert that it will fail. Then remember, Apple should have written fail because no, it's actually okay because the very first one has to fail. Then we have to make sure that it finally works by now implementing the proper code for a function. So then we're going to do what? Assert that. By now, I should have probably told you that. Sorry about this. Sorry that I forgot to tell you this. Build.gradle. Give me a second. By now, I should have told you that I already imported the Cacao. Cacao is for the UI testing. I already imported the truth library. If you're interested in checking it out, this is it. But if I didn't have it, I would have gone differently. I would have just done this. If I wasn't going to go with assert as, this is for the truth library, and I can see it has not yet been imported. I'm just going to remove this, so that then I'm given the freedom to choose the one that I want to import it with. So that's the common truth, and then I'll pass my result, and then assert that is true. Is equal to 4. Sorry?
Just a quick question.
Okay.
Before you I've seen that we have like the test implementation, we have implementation and the Android implementation. Maybe you can just highlight on the same before you maybe.
Oh, in the build Gradle. Oh, yeah.
Yes.
Okay.
Yeah, it's
Give me a second.
something maybe you can explain.
Okay. So thank you, Harun, for highlighting that. So like I had mentioned earlier, I think it was part of the very first slides I was talking of. When you have test implementation, this means that it's a dependency that's specifically targeting the Android, the test folder, so your local unit tests. But if you add the Android test implementation, then it means that it has access to your Android resources, so it'll be found in your Android tests. That also makes sense in the scenario that you can also do this. You can actually import the same library for something like truth to the Android test implementation. And now this means that you can actually use now use the truthy library in your Android test source set. I don't know if that makes sense, and sorry about forgetting to highlight that. So now we're back to our test, and the idea is the very first time we run it, it will fail. Let's see if it actually fails. So give it a second to run. Give it a sec. Oh, snap. Forgot about this. I don't know. Give it a second. Oh, is it going to shame me? So give it a second. Add. Oh, anilieka the wrong one. Guys, that nyinyi mlisahau kuniambia. So I actually used the wrong functionality that we were trying to implement. We'd only implemented, remember that I commented out most of the functionalities that I've already passed in, and currently we're only testing for multiply because we had to implement something for it. So let's see if it actually runs. So it's supposed to fail. And as you can see, was expecting 4 but got 1, because in here we're actually returning just 1. Now that it has actually failed with TDD, now you're supposed to make sure that it actually passes. Now you're implementing the real content of your app, of your functionality. Sorry. So multiply should be num1 by num2. So if we run the same test again, let's see if it actually runs. And as you can see, our test now actually passes. I should probably also mention that the green arrows you're seeing to the right normally means that for every single test that you write, let's assume that we were writing another one for, I won't actually do it because of time. Let's say that this one was testing for division. Okay, let me just go with anything for now. So let's assume that I had another class, I had another test for something different, for a different functionality, for a different function. Remember, it's for each test case, not that we're not testing multiple test cases in here. It's easy for you to now start saying like, okay, test for what? Results. Maybe we'd have to instantiate a different result and then pass here, maybe say something like 3F. Note that if one of them fails, na pole sana imeweza kuzunguka sana. Note that if one of them fails, it will be very hard. If you have so many assertions in here, it will be very hard for you to figure out which one failed. So each assertion is supposed to, each test is supposed to check out for each assertion. So now it's easier for you to know which one actually broke, and it's easier for you to even fix your code if anything happened. So I was talking about how you're supposed to run your apps. So you'll see that to every single function that I annotate with test, there's some buttons that show up here. If you click on it, you're given the ability to run that particular test. But if you want to run all your entire tests, you just click on this one, and it will run all your tests in this particular class. So now moving on to this other one, because of time, because I've already implemented it, I will just try and glaze over it. So the idea is now we have another Jam util. This is a class. Unlike that other one, this is a class, and it's supposed to give you a different ideology. Unlike what we did with, let me see if I can just close this one. Unlike what we did with this one, you realize that we were instantiating, we were just getting the values because we used an object, so we didn't have to create an instance of that object. Obviously, objects, you can't create instances, but what if you are creating, what if you're using But if you're using a class, and that is why we're going for this other one, the Util class. So this is the resource comparer, and this will give you an idea of how to write instrumented test. Instrumented test, remember, they're part of the instrumented tests and local tests fall under unit tests. The only difference is that instrumented tests, they're actually located in, when we look for the Util test, you'll find it under the Android test folder, a source set. So it's under the util, and you can see it where is this Android test? Yes, calculator functions, Utils. Give me a second. Oh, sorry. Close this. So you will see it under, so here it is. Let me see if I can open it next to it. So you'll find that how you actually create this, the class is pretty much the same way. I'm just going to go with Control-Shift-T, and you're given the chance to create a new test. We won't create one because we've already created one already. But then the same idea goes, plays in point here. So right about now, we'd probably just create the signature for our app, for our test function. But then we would create something that would return a falsy, and then we just test it to see if it actually runs by now writing the complete test. But then the idea here is, why do we have something different in case in point where we have a before, but when you look at something like a test, because when you look even at the imports that we're using, other than the before, we're actually using the very same ones. Because when you look at it, you'll actually understand that it's literally the same thing that we were playing about earlier on with. That's a local unit test. The only difference is the folder and actually has access to something like the context, which a local unit test does not have. But why would we use something like this? Why not just go with what? Let me just comment it out instead. Why not just initialize your value in here? And say, for instance, we had two tests. I'm hoping that by now I've not taken sijawatupa mbali sana. Let's assume that this one was returning a false. So why not initialize our value? Let me even comment this one out. Version util, I'm going to make it private. Version util is equals to. So we've instantiated our class. But now keep in mind that we talked about being careful about flaky tests. Like the fidelity of your app has to be high. Because in some scenarios, say for instance, like the Flutter app, where you're normally given an incrementer, you're normally given that fab button with the incrementer, where you click on it and it starts adding itself up in an electric jiongeza. What's the problem if all your dependencies, all your tests are depending on the same value? Not that tests are supposed to be independent of each other. No test should depend on the result of a previous test, because it might then lead to a chain of failing tests kwanzia yenye may fail. So the idea is all of them, they're supposed to be single units that have everything that they need on their very own. Say for instance, in this particular case, we're utilizing the Util. Assuming that we had a value in the Util instance that was changing. If we were playing with this, maybe we had a global value that would be potentially changed by this particular function. And then we run this particular function that builds upon the value that we get from this one. And this one already changed it. It means that in some scenarios, this might actually be a successful test where you have a false truthy and you have a false falsy. I don't know if my point is getting home. So the idea is you should definitely avoid using global values. Don't instantiate a class that might be dependent by one or more test functions. Instead, create a let init initializing. Unaweza kudelete kila kitu jameni. And then you use the before and after functionalities. Give me a second. So when you have something like before, this means that every single time you're running this method, I think I cannot delete. Okay, let me just say that. But the idea is now that you have the before method annotated before every single function, this will always be initialized for every single function that's run. So before this one is run, instead of using the global value that we're already sharing with all the tests that we have here and could potentially lead to a problem in the future, Now, before every single test is run, we create a new instance of that same class. And it also makes sense that we can also create the function that's a tier down. You're normally given this option to create these functions when you're normally given a chance to create these functions when Android Studio is creating your tests for you. So this one will be after. So after is run after every single, oh, what the heck? So after will be run after every single function. So keep this in mind. When we're trying to run this test, this will first be run, and then we get into the test. And once it's done, then we get into this. With tier down, mostly when you're playing with something like a database, you might want to maybe make the database instance to null. Maybe you want to remove the instance that you just created. It makes it easier on the memory, think of your device sphere. But the idea is to always have a clean setup for every single test, because all of them need to be independent of each other. And that's why we had a test. We had a test class, and we also had a test object. So that you see how you can use the two differently. And the final one is the UI test. Remember, we talked of the integration tests being a bit too vague, so I won't touch on that. Maybe that would form a follow-up class for this. But when we get to UI tests, let me get to my UI. So we get to our UI tests. The good thing about Android Studio is that it gives you the ability to actually record your motions, your click events, and it then sets up a test for you. So I'm actually going to do this, but the problem why I don't utilize Espresso recording for me is that it tends to be flaky. Like you'll have one test that you've just created and it won't work. You need to come and edit it later. In as much as it tries to pinpoint the specifics of what you just need. I know right about now it should be starting my emulator, so give it a second. Give it a second. So I'm going to do something like 8 plus 10. So what the heck? 8 plus 2 is equals, and you can see that the items that I'm interacting with are actually showing up here. So we're going to do is equals to 10.2. And then we can add, we're going to create this test. Select, so to finalize on your test, when you're creating this UI test for this, so you can actually click on the values that you have here. Is 10, save assertion, and now this one, I don't know if there's something I'm not seeing. Okay, it can be saved as main activity test. But then the problem is when you try to run this one, in some scenarios, it does actually over-engineer the test. I'm not 100% sure that this will run, but let's see if it actually runs. And then I'll show you a simpler method of just writing your tests with something like Kakao, which makes it easier to actually read. Because when you're looking at this, there's so many lines of code that you have to look through this. It's supposed to be starting my emulator, so give it a second. Let's see if it actually runs. Oh, it actually runs for the very first time. Mine always seem to fail, so I don't know how it actually ran. But if you're trying to go for something that was easier to write, you can imagine having to write all this for just that, clicking 2 buttons. If you're like me and you're lazy like me, you'd go for something like Kakao. Remember, you have to go into the Android test folder because this is a UI test. I had already created one. So when you're working with Kakao, the very first thing that you need to do is create a screen. A screen is basically a class. You can name it as whatever name you want to give it as, and then it inherits from the screen implementation or something, and then you pass the same class that you're trying to inherit screen from. And then the idea is you try to define all the widgets that you might need to interact with. In this particular case in point, it might be easy for you to actually figure out that this was a test where I was doing 1 plus, because there's the add button, 2 is equals to, we're looking for the value from on the very final view. but you might be asking what are the k-text views. So let's simulate one different thing. I could try and add the multiplication button. So I'll be say like button mode, and then when you're trying to identify the view, remember like with Espresso where we had the something on view, then with ID or with text or with what, it's always advisable to just go with ID. With Kakao specifically, to every single widget that you need to play with, you just append a K to it. But in some scenarios, you might actually not find that view available on this particular case or on this particular case, but they've tried to like highlight almost everything. I think the recycler view is the one that's normally found. So in some scenarios, you can actually go with KView. KView will still stand for your widget, or we can go with KText view. So there's no difference between using this and using this. It's only that this one actually specifies what you're trying to play with. So let me just go with KText view, because I already know that my buttons are actually text views. And I'll go with ID r.id.multiply. Ili kuinaitwa aje jamani? Let me find it. Give it a second. Multiply. Okay. So Kakao. Where are you, Kakao? No. Multiply. Hey. Sorry about that. Give me a second. Text view. Multiply. Why is it not showing up? Oh yeah, I remembered. In some scenarios, it may actually fail to appear when you're trying to type it. Utaona hapa it's resolved okay, but when I was trying to type it, nikijaribu autocomplete haiko ina show up. But all in all, you just have to initialize the views that you need. You're just trying to find them. Okay, you're not initializing them, but you're just identifying the views on your screen. When you're playing with Kakao, when you're writing tests with Kakao, you work. Your idea is focused on a particular screen, doing a particular series of things. So the only thing you need right now is to just identify the views that you'll be playing with. Remember when I was talking about UI tests, there's no need in point for you to test something that's static. You won't be interacting with something that will actually yield a result to a user, and you're trying to see if it works out correctly or it does not work out. It's flaky, if I may say. So now that we've already located, we've already initialized all the values that we need, all the views, all the widgets that we need from our app. The next thing would be to create the test. Now the test is not as hard. It will literally it will almost model what you just saw with Espresso, because actually Kakao is built on top of Espresso. So the basic idea is that the test should definitely be the name of your class followed by a test, followed by the word test. That's the best, the most basic and the best naming convention that you can go for, and highlight it as a large test. I mentioned earlier that some of these annotations that you'll find with the large test, you'll actually see there's a drop down there that explains what it's for. In most scenarios, it's used as a filter so that you can be able to run most of your tests as one group. Large tests are for the UI tests. Small tests are for your instrumentation and sometimes integration tests, and small tests are for your unit tests. Specifically your local tests. So the next thing is to create a rule and the JVM field, just as we had seen with Espresso. We're now starting main activity where we'll be interacting with the only thing that we'll be interacting with in a particular screen, and then we instantiate it. We instantiate the method that we created earlier, and then we write our test. Say for instance, now we're writing a different test. Let me see if I can just hide this one, so that you can see how easy it is to create a test with Kakao, unlike that other Espresso thing that we're writing like 1,000 lines. So the idea is the very first one we wrote was we're trying to implement something for multiply. So let's annotate it as test, and then fun what to 21. Okay, it's not good to write numbers in your whatever names. So 20 multiplied by 2 equals equals what? Equals 40. And then we now start to interact with our test. So what do? The very first items that we already found. We are literally now simulating what we're doing as a user. Now you're clicking on the buttons. So I'm probably going to click on 2, then 1. But the problem is I actually didn't even initialize the zero button. So let me just change. Okay, let me just initialize the 0 button here. Val button 0 is equals to k text view with ID id.0. Awesome. That was easier to find. Do you have number 2? Okay, I have 2. So we'll have k what? Number 2. Button 2. Kanakata kutokea. I swear this thing is just playing mind games with me. I almost forgot about that. Sorry about that. We first have to use the screen that we just initialized earlier on that contains the items that we want to interact with. And then I'm going to go with, sorry about that. And then I'm going to go with button 2 dot click. It's as simple as that. Then we can move on to button 0 dot click. And then the next one we're going to do is button multiply. Mult.click. And then the next one is button, we're multiplying it by 2. So button 2.click. And then we're going to assert that it actually checks out that the result. Oh, then we click on the equals button. Button equals.click. So that we get the total. And then we're going to do, I don't remember what the very last screen is called. It's called the total screen. So the total screen dot has text screen. So we're testing to see if it actually returns the value that we're expecting, which would be 40.0. And let's see if it actually checks out. Remember that this one should actually run successfully. I didn't follow the TDD paradigm in this particular one, but let's see if it works out okay. Give it a second. Thank you. And it ran successfully. So ladies and gentlemen, that sums up my presentation for the day. Hopefully next time we'll have a more advanced one for some of you novices, and that sums up my presentation for beginners basically. Thank you. Back to you, Haran.
So thank you so much, Wachira, for the amazing session. So before I say my final words, I'll ask do we have anyone with a question for Wachira? This is the time. I'll quickly look up on the chat. Okay, I think, go ahead.
Wachira, you mentioned something about the large tests, medium tests, and small test annotations. Would you kindly clarify those?
I'm actually even going to share something about this. Give me a second. Oh, I'm still sharing my screen. I think I had a folder that was still open for. Oh, okay. So I think this is the best thing that I can help you with. So then the mostly annotations that you have to pass in your tests, in some scenarios, like if you look at a local unit test, we didn't pass them, but from the resources I was looking at, you'd in some scenarios find the annotation small, medium, and large. With small, it tends to signify that test is a local unit test, but it also limits it on its abilities. Like these are the abilities that particular test should be able to do. And actually, this one can be found on the Google Devs, I think, page or something. But the idea is they're filters so that you can be able to run your tests as groups based on that particular filter. I don't know if that helps. Ama nimekuchanganya zaidi.
Kuna shortcomings usipo obey that.
Sijacheza nazo sana. Yenye nimecheza nao mostly ni kwa local unit test. Kwa hizi zingine sijajaribu. I haven't tried to run it without. But on the local unit test, it didn't fail. Yeah.
Okay, thank you. Thank you.
So we have another question on the chat by administrator. Where do tests with laboratory fall? I think in the regards to the integration unit test or UI testing?
Oh, I think personally, and that's why I didn't even jump into them, because these are certain stories are using stubs and using mocks. In some scenarios, like the resource I was looking at when looking at integration tests, when you're testing something like room, in such a scenario, you had the freedom to use roboelectric, but then they're also limited. In some scenarios, you're told that something like there are certain places in which something like roboelectric will fail, where an emulator will be really good at. Because in some scenarios, you're also trying to mock up things. You're also trying to mock up some of the classes. Some of them, like you can mock even a context. But honestly, I have not looked too deep into that. So probably me saying morning on zaidi. Yeah.
Okay, I think Administrator, I hope you've been answered. And then we have another question by Benson. Can you automate this? I think regarding to the tests.
Can you automate so that your tests are written for you?
I'm not sure. Maybe Benson can ask the question.
So it was more that if you have easy way of exporting the configuration so that it might run, say, on some other machine. If you're working in a team, then usually you want to share the tests as well, and you have a separate testing machine.
I don't know. Maybe Harun unaweza jaribu kujibu hiyo. I think I'm a bit confused.
Can you come up again?
I mean, if you can export the configuration and then it'll run, let's say, on another machine automatically and go through all the tests.
Or like,
so for example, you have this for the tools that you use or the tools that you demonstrated. Okay,
I think the most easiest way to do this is having like a CI/CD pipeline. Mostly you have like, for example, on GitHub, maybe you have GitHub Actions, depending on the CI/CD pipeline tool you use. We have Bitbucket pipelines, we have GitHub Actions, and so on and so on. So what you do, maybe if you want this test to be like available to the whole of the team, you add like I'll use like the actions example. You have like steps where you first run the tests, all tests, unit tests, integration tests, and also the UI testing, and maybe give the report before the PR is merged. So you'll see something like you have 6 checks. Maybe one is failing because maybe the test are maybe failing. So with that, at least everyone in the team can see this test is failing, and maybe before you even merge that sort of a thing, you'll be able to see that. So mostly that is how teams usually do, just pushing it a level higher to the CI/CD pipeline, so that before anything else, you first test the maybe changes and then make sure that they are working. I don't know if that answers you.
Okay, thank you.
Just to assert what Haruna said, yeah, if a pipeline is set up, you can do test anywhere. I've seen it in application.
I mean, for the tools that are demonstrated, you can export a configuration.
Yes. If a pipeline is well set up through the GitHub Actions.
Okay, thank you.
Oliver shared something of the same on the showcase. Yeah, maybe. Yeah, but you can always share it on the CI/CD pipeline. That is usually the best place to do it in case you're working on teams. So without taking much other time, we have a question by Brains. So how do you make sure you cover all functionalities in your tests?
So the idea is TDD. Before you even write that function, the functions what? The functions, what's it called? The content in your function with TDD, you're first supposed to write the tests, because you're now testing for something that does not exist. So the idea that now you're working backwards forces you to cover every single thing. But then that again also emphasizes on the idea of scope. Your tests need to be specific, and your tests also need to work on what? modules that have been broken down to the lowest possible unit that you can find. But the idea is that now that you're working backwards, it will make it easier for you to test for everything. So I think that's priority. Oh, sorry, someone else has something to add.
Sorry to interrupt. I just wanted to add something onto that.
Okay.
I just wanted to add something onto that. What you just said, huh?
Please.
You can also use code coverage, so you can actually know like what percentage of your tests are actually of your code is actually being run. It's a good metric.
Yeah, like code climate.
Yes, or Jakoko.
Yeah, definitely. Thank you.
So another question for you by Roland Goodfellow. What is the place of snapshot testing in Android? Does anyone use it?
Snapshot.
Yes, snapshot testing.
Maybe open up the floor to someone else to respond to that. Honestly.
So anyone who has an idea? Or maybe Roland, you can maybe.
Can he come again? I missed that.
So the question is,
Yes.
let me just read it again. Hold on. I think it's about snapshot testing. What is the place of snapshot testing in Android? And does anyone use it? Is that clear?
Yeah. Let me get back in a minute. I'll try answer that.
Or maybe Roland, you can try to shed some light.
Okay, cool. Snapshot testing, I think it's mostly used probably by JS guys who write JS code or probably iOS code. But basically it's a means of comparing a snapshot of the UI. So basically you take a snapshot, the binary snapshot of the UI as it is. And then on every iteration, you compare with the previous snapshot, right? So if there's some disparity, then some of those tests will fail. So the idea is to ensure consistency in the UI and that changes in the UI don't break things. Yeah. So think of snapshot like a binary capture of the UI in memory, right? And then it's stored somewhere, and then you push it to your CI. So anytime there's an iteration, it compares with the new iteration compares with the old iteration and just basically checks if there's some breaking changes. That's all it's about. So we see this mostly in JavaScript or probably React Native with Jest. Jest is a framework for writing UI tests in React Native. So that's all about it. I was just wondering if it's a common thing within Android developers and if anyone was kind of using it at his workplace, just to kind of give us an idea where that would fall in Android testing. Yeah. I think we also have frameworks like Spoon, for example, which would allow you to, sorry? Yes, Ollie?
Yeah, I've heard about that.
Yeah.
Some people do it in their CI/CD pipeline. And if you want to get a good example of how large companies use it for their apps, there's a talk with some engineers from Monzo. You know Monzo, the virtual bank.
Monzo virtual bank.
Yeah, Monzo.
Okay.
Monzo.com.
Right. Oh, okay.
Yeah,
cool.
And they have a talk where they explain in detail how they do their pipelines all the way to production, and they have a step where they do such.
Okay, we'll try to look them up. But if you can find the link, you can probably share. Yeah, please do. Yeah. All right. Thanks. I guess that's it.
Okay, thank you. So I think maybe the last question is the UI written in Compose? If not, how does this affect the tests? Maybe I think it's about the Kakao.
Oh, Kakao. I haven't tested Kakao with anything like Compose. But what I was testing with with XML. I don't know if it will be different, if it will still run the same, if it even supports it. Acha tuiache hiyo kama homework yako. I honestly don't know. I'm not sure. Maybe someone else who might have an inclination to how that goes. Maybe.
I think Wama, was your question if the UI is written in Compose, or what was the question?
Yes. Like let's say if you had used Compose, how would the test change? Because I've not actually dug into Compose. That's why I'm asking.
I think if it is Compose, we have also specific like test libraries for Compose and so on. But I've also not like tried out Compose. I'm still waiting for it to be stable. So I cannot speak much. Maybe Oli has some bit of experience on Compose.
Hi.
Hi.
I think if you were to swap Compose with the XML in this example, all you'd have to do is replace the with ID with something else, maybe with text or some other identifier, and then everything else would act the same way.
Wow, okay, thanks.
Okay, I think we don't have any other question. Maybe there is a comment by Roland, maybe which I think I'll just read it out. Writing tests for interfaces and only inject concrete class. Once concrete class is fully implemented would really help in TDD mindset. I think, yeah, that is something that will help when you have like tests for interfaces, and then once the concrete class is fully implemented, it can help you like in the TDD mindset. Yeah, so I think that is it from the question side. There was someone who was asking if you'll share the presentation. So
it's okay. I'll make it shareable, then share the link in the chat box.
Okay. So thank you so much for the amazing session. I think as you can see from the chat, everyone is saying good job and good presentation. And this being your first presentation, I think big up to yourself and also for the amazing presentation, especially on testing. It's usually a topic that doesn't have much resources, as you say, but you've done an excellent job to highlight the key areas that maybe one should focus on. And as you said, maybe anyone here or yourself can take up the challenge, maybe to also do another advanced session on testing too. We still have more slots remaining for the rest of the year. And we welcome those kind of sessions. At least we get to discuss the things that we work on daily. Thank you so much, Wachira.
Thank you very much. I think I'll try that. Asante sana. And thank you guys.
All right. So I think, Benson, you're up next. It's your time.
Thanks. I'll share my screen. And we'll get started. So, guess I'm also developer, much more on server-side computing, and so I've kind of been looking at this particular library because I can kind of use some of the techniques that I'm used to and apply them in mobile. So I'm approaching this from the point of view of some very much on mobile, but I hope it's still helpful. So I'm going to look at using a library called SDL, and want to use this for games because it allows you to do kind of nice interfaces in a portable manner. And so kind of main aim here is you want to have cross-platform games and maybe other applications as well. But we start with games just because of, usually you want to start with something not so serious and develop your skills. And then I'll discuss the library and then two very simple games that might kind of serve as starter projects. I won't really discuss Vulkan. I haven't had as much time on that as I would like. So slides are online, and the idea is that we typically have a problem these days because you'll have to develop for iOS, Android, desktop as well. People are looking at kind of different solutions for this. One is, for example, Flutter. But it's also possible to use a few libraries in C and have something that allows you not to repeat too much work and maybe get higher quality because you can focus on the quality rather than the quantity of code that you develop. And so when I was starting to do this, the first thing I came across was a terminal program that was described actually in an Intel blog. So that's in this particular slide. And the author was actually describing how to use these tools from the Android toolchain to compile a C application and get it to run. So 5 years ago, it's kind of a hello world application. So you can go through how you install it and set it up and set up your build environment. Does it for both Linux and Windows and get something to run. And at least for me, I tend not to like IDEs too much. So I was also quite excited that we had a standard configuration, which you can see here in a makefile in addition to the IDE. So this is kind of helpful. It meant that you could get something running and kind of tried that out, implemented it and put it in a pipeline. So this one actually kind of works. The code itself is maybe not too complicated. So there's a pipeline to compile it. I'll just give you some idea of the type of code that's there. You have a couple of makefiles to describe how to compile it. Generally, Android Studio would hide most of this from you, but it can be helpful to expose it sometimes as well. And it just prints out, Jumbo Dinia. So this is in C, and you can then set up a pipeline that'll actually build it, which is handy. So in this case, the pipeline produces an executable, not an APK. And you would actually just set up a terminal on your phone to run this. And so this is kind of setting up the environment, at least for most of them, that installs your compilers and tools, just does it in a command line way, and then builds it using NDK and produces the executable as an artifact. So you can actually download that, which is quite nice. Especially if you're going to do that will be something that will be nice to integrate with these kinds of tools as well. So once you've done that, the next step is to try and see if one can produce graphics. And so there's this library, the simple DirectMedia Layer. It's completely open source. You can embed it in your programs. You can use it in commercial programs as well. It has bindings in many other languages. So if you're maybe working in a small team and you need to develop mostly say desktop apps and have some kind of mobile interface as well, this may be helpful. It's fairly low level, but there are lots of online tutorials and it actually takes care of the portability problems for you. So it'll run Mac, iOS, Linux, and Windows. And it's about 4 megabytes. So for some phones, this is maybe still too large. You might try and strip some of the things yourself. And at least in my experience, experience. Usually when you produce an APK, you link everything together. And so if you have several apps like this, you might find that that takes a bit of space. But if your target market tends to have high-end phones, you're probably okay. Or if it's maybe a crucial app for somebody, then this might still be a useful thing to have. So this is kind of a screenshot showing kind of one of the games. And the idea is just counting. So you get a random number between 1 and 10, and it's set in Swahili, and then you kind of have to press the right button. So fairly simple, and then kind of in this case, the matatus move. So that's the desktop version. And I guess that's also available. You can look at the code and if you want to try and play with that. So I've mostly focused on building for Linux. You can build for Windows as well. And the next step was to try and build it for mobile, primarily because at least some of the people I'd be interested in trying it out are much more likely to use a phone or a tablet than they are to use a laptop computer. So this is kind of first attempt. You see a screenshot of my phone here. And you see the matatus in the background, the numbers. So slightly different layout, just because of the sizing. At the moment, it's not dynamic. But it mostly runs. There may still be a few bugs, but I was kind of happy with that. So porting it kind of tested on Android 4.1. So I couldn't use the latest version of the library. I used the version that was about 2 years old. And I don't know if people actually have issues like this. So I was kind of quite surprised on the range of kind of phones that people may likely have, at least here. So I don't know if 4.1 is kind of a lower limit, or if you find others and you need even more portability than that. I spent a bunch of time looking at tutorials, and at the end, I found that the documentation for the README was actually very helpful. It actually has a script, which means that if you have a desktop version running and you don't have too many extra libraries, then it becomes quite easy to port. You just run the script and it does that for you. So maybe I'll show the, okay. So this is a broken pipeline. I'm still trying to get that to work. But it actually does build, at least on my own computer. And so this integration pipeline, the code is actually, I just embedded it within the library, took a release version. As you can see, there's examples for each of the things. And what they have is this very nice build script. Sorry, I went back up the, okay. Here we go. So he has described here kind of a nice build script. One to build the libraries, another one to build actually in Scripton, and it generates WebAssembly. So you can also have a web version of this code, provided you're not interfacing with things that are too complicated. But it kind of describes how to use it here. So you run the script, you put the name of your app, and you have a list of your sources. And provided the sources were kind of compiling on your desktop version, you almost immediately get a mobile version. So once you understand that, it takes you maybe about 10 minutes to get your first mobile version. Then you probably want to tweak it just because of things like screen sizes and sound. If you have a chance, maybe take a look at these materials. There may be cases where you're also looking for better performance out of your Android app. And so you might want to write some part in C, or at least link to a C library. And this can help you do that, at least these techniques. So I'll still polish this a little more. I'll probably look at putting in an F-Droid. The terminal, I guess, at least on my phone, is about 2 megabytes. So this app is actually at least maybe relatively heavy for an old phone. But I was actually quite happy at how fast it was to transform. And in terms of Vulkan, I had hoped to discuss that. But the main hope there is that you can actually use this to do GPU computing on your phone. And so that's, again, low level. You would link it through the NDK as well. But I think you need Android 5 to be able to get Vulkan support. So I haven't done that so much on the phone. And that's it. So make sure that we finish on time today. So I guess most of you will learn Java, but take a look at C as well. You might find that there's situations where it might be helpful in increasing your productivity or the performance of your apps. So thank you, and I'm happy to answer any questions if there's some.
Hi guys, thank you Benson for the presentation. Anyone with the questions, please can start asking them here, or you can post them on the chats.
Okay, I have a question, and you talked about your app being cross-platform, Windows, Linux, Android. So, assuming maybe I started with writing my app with, for instance, I wrote it on Windows and I saw it was working well. So if I'm to port it to Android, what are some of the implications that I might face, or what are some of the things that I should probably focus on? Maybe it will affect my app in the end.
So I'd say composability. You really want to think your app is having some kind of front end and a back end. So the back end should be portable because you just recompile that for each of the different platforms. The front end and user interface, you might want to change a little bit, or at least query and have it so that it adjusts itself appropriately. Usually for a desktop app, you can fix the size and people will move things about, right? They don't necessarily have to maximize for the whole screen. But when you're mobile, screen sizes will vary, and people usually want to maximize or even zoom in further. So somehow allowing for that in your application is helpful. Second thing that you might consider is power saving modes. Well, laptops will usually do this as well, but you might consider settings for your application where you kind of don't run it at full speed. You kind of have a sleep mode if it's necessary. This is not so much useful for a desktop because you're usually connected. But if you're moving about and you want your phone to last a day or two, then this becomes an issue. But I mean, other than that, I mean, the porting time is relatively quick once you understand it. So there's a learning curve trying to figure out how the libraries are composed. But once that's done, then it's actually fairly quick. And the SDL library actually has lots of good, I guess, examples, I'd say, but they're also tests. So that surprised me as well. That may help speed up development if you're looking at doing that.
I think we have a question from the chat by Brent. Yes, so apart from using the terminal, is there an IDE you recommend you can use to write the programs?
So I mean, I tend to use VI a lot. But you can use this in Android Studio as well. So if you're mostly a mobile developer, Android Studio supports NDK and linking things through that. So the tools are not really tied to any specific IDE. So use what you like. IntelliJ if you want, or some of the JetBrains products, code blocks, Visual Studio. All of those will work fine.
Okay, one of the main concern that as an Android developer normally focus on is to do with Apk Size. You've seen their apps. I've seen apps that are around 200 MB, especially ones that tend to be like video games. So if you are not been developing in Android for some time and you come to it, you will have a problem with that, because every time these days I see both Android Studio and even Play Store console, they normally give you warnings about the Apk size. So how are you gonna factor in that when you are building your app? Because I want to believe that for every app that you will be building with whatever game SDK you have chosen to work with, you are going to build it with everything that it needs for it to run. So how do you deal with Apk size?
Okay, so when you say 200 megabytes, I mean, I'm concerned because you know, you have old phones which have maybe 100 megabytes or so, and especially being in Kenya, where most people do not have a smartphone or do not have a high-end smartphone, this really affects usage of your application. So the C part actually is fairly light. You can code it well. What tends to be an issue is if you statically link everything, then you're going to repeat using this kind of library. Or if several people use this library to create an app, there's no kind of good way to share that. As I said, it's about 4 megabytes on its own. If you add up the other modules, you might get up to maybe about 15. So in this case, for example, I transformed pictures from using PNG format and JPEG format to using a bitmap, because then I don't need the image library. This actually helped reduce the size. This is an issue with many games as well. They'll ask you to download the assets separately. So that might be another way you could minimize application size, only downloading assets as you need them. Drawback is then you need internet connectivity.
Maybe let me just add something that it might be helpful, because this is something that I was researching on, because I normally build desktop apps using C# and at times C++. So when it comes to Android is something that I do when I'm not very busy. So basically, some of the tips that somebody might want to put into practice is there are games that have been divided into multiple APKs based on maybe subscription models. And then, of course, you can adopt good UX best practices, check whether a game is running instant experience. Okay, or even you can transfer data to an installed experience. And then, of course, I saw there is something like there are tools. I think there are around 3 tools that can help somebody to reduce the size of the app. There is the Apk analyzer, and then there is also a Bloty MC boldface that shows the size of the binary files. And then, of course, Android GPU inspector. This one will help you to see the file size effect during text size without having to recompile your game. And then, of course, you've mentioned that one of images, which is even very important even when you're not even building a game. So those kind of things that will help, so that at the end of it all, you tend to have an app that is not very big. Because if a user sees a game that is around more than 100 MB, they might not want to install it. Then another thing I'm also, I think you can also add to that is that when you choose the Gradle version that you're going to use, probably Gradle 4.4 and above, they tend to generate smaller DEX files, which will mean that your APK size is going to be manageable. So, of course, those kind of things, they will help in the long run.
Thank you. That's helpful.
Do you have anyone else with a question for Benson? So I think I'll take that as a no. So maybe, Benson, where can people reach you in case they have more questions about SDL, games, and so on?
So the slides and are all online, and the code is also in GitLab in this case. I can put the link to the slides in the chat again. My contact information is also on there. So feel free to fork and build on it. I'll probably add, well, yeah. Do attribute the other people I've built on, but yeah, should be easy to reach me.
Okay. And thank you so much for the presentation and for your time. And also a highlight on SDL and building games for cross-platform. So I think after this, we'll have people going to play around with that and maybe just seeing what they can build on that. Thank you so much.
Thanks for your attention.
Okay, I think I want to invite Candy to maybe wrap up, but before I do so, maybe we have Michael, who is also hosting another meetup later on today. Maybe I can give him maybe a couple of minutes to introduce and speak about the same. Michael, if you can hear me.
Yes, thank you, Aaron. My name is Michael Timadi. I run 3 communities, that is Atlassian, MongoDB, and GitLab. So today we are hosting Atlassian from 4 p.m. today. And I invite all of you, if you can make it to Arab. We'll have a nice conversation reviewing some tools that Atlassian announced. And yeah, welcome.
Okay, thank you. So Candy.
Hi guys, thank you so much for attending our session. It's always an honor to have you all. Also to our amazing speakers. I really enjoyed the session and I'm so happy you guys signed up to speak. I understand that most of you, Benson and Wachira, I understand this was your first time speaking on Android254. It's really amazing to have guys sign up to speak and do an amazing presentation like you guys did. We normally don't take that for granted. Kindly do share your slides so that anyone that wishes to go over them and play around with your code, they can do that. Also, thank you to the participants who are able to like chip in and contribute and share what they know on that matter. I really appreciate you all. If you wish to speak also, there's a link that Harun had already sent on the chat. Please sign up to give a session as well. Also, we do app reviews. If you're developing an application and maybe you want somebody to give you your reviews and you know what they think about it and what you think you can improve on, we normally hold those sessions as well. Harun is gonna share the link on that also. Thank you, Timadi, for your today's session. Guys who are able to join, please RSVP to Michael Kimathi's event and let's attend and learn. My name is Kendi. Thank you all. Good day.
Bye.